So welcome to this lesson on physics. So in this lesson we'll be treating introduction to physical quantities and units. So let's start with the lesson. First off, what are physical quantities? So physical quantities are measurable properties used to describe the world around us, and they form the foundation for scientific understanding and allow us to quantify observations. So now there are I can say there are basic physical quantities, and there are some that are kind of like derived from the basic ones. So they call these kind of physical quantities the fundamental physical quantities, and the other ones they call them the derived physical quantities. But while we go into this lesson, we would see we would understand these physical quantities properly. So some examples of these physical quantities are we have length, we have time, we have temperature, we have mass, and so on. There are several others. So each of these ones they try to help us to define specific aspects of phenomena in a standard way. So as I said, this lesson is talking about physical quantities and units. So units, on the other hand, and measurements, they are kind of measures that try to describe physical quantities, or that try to describe quantities. So and the measurements are what these units try to record. So the units try to record measurements. So measurements are depicted in terms of different units. So this topic explores the definition of units and the types of physical quantities, and also their critical importance in ensuring accurate and consistent scientific measurement across various fields. So let's move on to our next slide right away. So here we have that we'll be starting with a definition of what units are. So from what we have on my screen, I said units are standard measurements used to express physical quantities, which was what I just stated in the previous slide. I said units are used to measure physical quantities. So examples of these units, we have meter for length, we have kilogram for mass, and we have seconds for time. We also have Kelvin for temperature and several others. So units, they are used to measure quantities. Units are used to measure quantities. So now there are several types of units. We have the CGS units, we have the SI unit, but basically in physics we talk about just the SI unit. So SI unit actually represents International System of Units. So internationally systemic units. So it's not really an English word though, in the way that they gave it, the way they try to form the SI units, it's not really from English, but the meaning in English is the International System of Units, representing SI. So this unit system is widely used, and it's because of it's kind of consistent over most quantities. So you can use it to serve as a base or a basis for other measurements or for different quantities. So let's move on to the next slide. Unit conversion. So unit conversion is how we move from one unit to other units. So as I was saying in the previous slide, I said we have CGS units, we have SI units. So when we move from SI to CGS units, or from SI unit to any other unit at all, that is called unit conversion. So from what I have here, said is the conversion that involves the changing of measurement from one unit to another while maintaining the same physical quantity. So for example, we can see when we try to convert length from meter to centimeter, meter is actually the SI unit for length. Meter is actually the SI unit for length. So now if you're moving from meter to centimeter, you're moving from SI unit to CGS unit, and that movement is what is known as unit conversion. So it can be seen also in the case of moving from kilogram to grams. So this particular unit conversion is essential to convert units correctly to ensure consistency in significant calculations. So now there are several methods that are used for measuring length. So let's focus on just one of the units, or one of the physical quantities. So as I said we have several physical quantities like mass, length, temperature, and so on. So we'll be focusing currently now on length. So methods for measuring length. So we have normally the use of rulers and tape rules. So this is very common. Most of us, we've seen rulers, we've seen tape rule. So another measure, or another way to measure length, is by using some precision instruments known as caliper. So these calipers, they look like this, like what we have on the screen here, and they are used to measure things on smaller level that your normal meter rule cannot measure. So we also have another one that is known as micrometer screw gauge. So this micrometer screw gauge it measures way less length or distances. It's used to measure way lesser lengths. So the importance of the importance of these measuring methods or these tools is that they help you to get um, a particular representation of a particular physical quantity. So from here, I said that for higher precision and smaller scales, calipers provide accurate measurement, and for internal and external dimensions, they are used also. So they are essential in engineering and manufacturing. So the choice of measurement method depends on the required scale and precision. So accurate length measurement is crucial for reliable scientific experiment and consistent results. So when you talk about precision, precision is talking about how well targeted something is. So how close. Let's assume if you're trying to talk about precision. Let's say we're trying to talk about precision. We want to see how precise someone's shot is. Let's assume we have something like this. We have a bull's eye. Sorry, we have a bull's eye measurement. Sorry, we have a bull's eye. All this stuff that they throw darts on. So assuming we are trying to use that kind of thing, let's say something like this, a circle that has different center point. That's a bull's eye, and that's the center. If the target is this center, the bull's eye, if we are to shoot, precision will be when we are trying to shoot and we are having. Let me try changing the color of this so we can be able to recognize when we are what I'm talking about. So when we shoot and when we are trying to shoot and we are shooting at this point, say here, we shoot at the same point again, we shoot at the same point again, shoot at the same point again. So these four shots are precise because they are close together, but they are not accurate because the real target is this was main target. You get? So precision does not have anything to do with accuracy per se. It's just talking about how close your how close measurements are to themselves. So that's what precision is. So let's move on to our next slide. Let's move on to our next slide. So here we have methods of measuring masses. So we've talked about how they measure lengths. We talked about how we measure length. So now we have how masses are being measured. So for mass measurements, we use stuff that are known as balances. So balances are used. Either it could be a weighing balance or a beam balance or a digital scale. So they are used to measure mass. So and the method for measuring these stuffs is usually depending on the mass range. So what will determine the instruments you use is going to be how small the weight is or how large it is. So if something that the weight is very light, you will make use of stuff like the digital scales. So these ones are used for these purposes because they can measure very small scales of masses. But if you want to use large size measurements, you probably use something that can be able to stand weight. So the methods is dependent on the range of mass, and with more accurate instruments, with more accurate instruments used for smaller masses. Just trying to explain why I said we use weighing balance, like the normal standard weighing balance. These ones are used to measure tiny weight or lighter weight, and you want to get higher accuracy. So now the SI unit for measuring mass is kilogram. Kilogram is used for measuring masses. So next, let's move on to how we measure time. So time is measured with clocks or stopwatch. We are all of us are familiar with this. Time is measured with stopwatch or stopwatches. So for precise measurements, instruments such as atomic clocks are used, and especially for scientific researches. So time is typically measured in seconds. The SI unit for time is in seconds, and time is a very fundamental quantity in physics. It's a very fundamental quantity because it does not really have a replica. It's just time. So time is time. They don't have anyone that is probably close to time, but just time. So it's very fundamental. Many other quantities in physics are gotten from time on its own. like Newton is a function of time. We have force is a function of time, determined by Newton. Acceleration is a function of time. Velocity is a function of time. So time is a very fundamental unit because from it many other units are being derived. So let's see. In this section, we've been able to try to introduce what physical quantities are, and we've also tried to see how these units provide standardized ways to measure and compare quantities, and also we've tried to see the importance of correct units and of conversion and also measurement. So I remember saying from this lesson that units are used to measure quantities, and units can be converted from one system to another, either SI or CGS. So they can be converted from one unit to another. So, and also I also talked about precision and accuracy. So accuracy has to do with when we are getting readings that are close to each other. So you can say, sorry, precision is when we have readings that are close to each other, but we can say things are accurate when we have stuffs that are hitting the exact point. So for you to say something is accurate, you need to have a target. For you to say something is accurate, you need to have a target. So how close to the target it is what determines how accurate it is. So you cannot say someone is probably a good sniper if the target was to shoot the head of a particular statue, and the person actually made 5 shots on the stomach, hitting at the same spot on the stomach. The person does not have an accurate shot. The person has a precise shot, but it does not have an accurate shot, because precise in the sense that all 5 shots hit the same spot or close to the same spot, but the person is not accurate because the person cannot adjust himself to shoot the real target. So there has to be a real target before you talk about accuracy. So now we also talked about different instruments and methods that are used to determine to carry out measurements of units. So that will be all for this lesson, and I'll be saying goodbye.